Volcanoes. They are among the most awe-inspiring and terrifying natural phenomena on Earth. These fiery mountains have fascinated and frightened humans for centuries. Their eruptions capable of both creating and destroying landscapes in a matter of moments. They are windows into the fiery heart of our planet. When a volcano erupts, it offers a rare glimpse into the powerful forces at work beneath the Earth's crust. The molten lava that flows from these geological giants is a reminder of the intense heat and pressure that exists just below the surface. These geological giants remind us that beneath the seemingly solid ground lies a world of immense heat and pressure. The Earth's crust is like a fragile shell, and beneath it, the mantle churns with molten rock and gases. This dynamic environment is constantly changing, driven by the heat from the Earth's core. Volcanic eruptions, as awe-inspiring as they are destructive, are a testament to the incredible forces that have shaped and continue to shape our planet. These eruptions can create new landforms, such as islands and mountains, but they can also cause widespread devastation, destroying everything in their path. But what exactly causes a volcano to erupt? The answer lies in the complex interplay of geological processes that occur deep within the Earth. Scientists study these processes to better understand and predict volcanic activity, which can help mitigate the risks associated with eruptions. Imagine a bottle of champagne being shaken vigorously. The pressure inside the bottle builds as the carbon dioxide gas is released from the liquid. Eventually, the pressure becomes too great for the cork to contain, and it pops off with a burst of foam. The pressure builds until the cork can no longer contain it, resulting in a sudden, explosive release. This is similar to what happens in a volcanic eruption, where the pressure from the gases and molten rock becomes too great for the Earth's crust to contain. Similarly, a volcanic eruption occurs when molten rock, known as magma, rises from deep within the Earth and bursts through the surface, often with tremendous force. This process can be triggered by various factors, including the movement of tectonic plates and the accumulation of gases within the magma. This essay delves into the fascinating process of a volcanic eruption. We will explore the journey of magma from its origins deep within the Earth to its dramatic emergence at the surface. Along the way, we will examine the different types of volcanic eruptions and the factors that influence their behavior. We'll journey from the depths where magma is born to the moment it breaches the surface, forever altering the landscape. This journey is not only a testament to the power of nature, but also a reminder of the delicate balance that exists within our planet. Join me as we explore the science behind these powerful events and examine their profound impacts on our world. From the creation of new land to the destruction of entire communities, volcanic eruptions are a powerful reminder of the dynamic and ever-changing nature of our planet. To understand volcanic eruptions, we must first venture deep beneath the Earth's surface to the realm of magma. This journey takes us into the very heart of our planet, where the forces of nature are at their most raw and powerful. Here, in the depths of the Earth, we find the birthplace of magma, the molten rock that fuels the fiery spectacles we see on the surface. Magma, the lifeblood of volcanoes, is molten rock that exists beneath the Earth's crust. It is a seething, bubbling mixture of molten minerals and gases, constantly in motion, constantly changing. This molten rock is the source of all volcanic activity, the raw material from which volcanoes are born. It forms in regions where temperatures and pressures are extreme. These conditions are found deep within the Earth, where the heat and pressure are so intense that solid rock melts and becomes liquid. This process is known as partial melting, and it is the first step in the creation of magma. One such region is the mantle, a layer of hot, partially molten rock that lies beneath the Earth's crust. The mantle is a vast, dynamic region, constantly in motion, constantly changing. It is here, in this turbulent environment, that magma is born. The mantle is constantly churning due to the intense heat emanating from the Earth's core. This heat causes the rock in the mantle to move and flow, creating currents of molten rock that rise towards the surface. These currents are known as mantle plumes, and they are a key part of the process that creates magma. This heat, a remnant of our planet's formation and fueled by radioactive decay, is responsible for melting rock and creating magma. The heat from the core is so intense that it can melt solid rock, turning it into the molten material we know as magma. This process is ongoing, constantly creating new magma deep within the Earth. Another magma-forming environment exists where tectonic plates, the massive slabs that make up the Earth's outer shell, collide. These collisions are incredibly powerful, generating enormous amounts of heat and pressure. This heat and pressure can cause the rock at the edges of the plates to melt, creating magma. These collisions can force one plate beneath another, a process called subduction. In a subduction zone, the descending plate is pushed down into the hot mantle, where it begins to melt. This melting process creates magma, which can then rise to the surface and fuel volcanic eruptions. The descending plate melts as it plunges into the hot mantle, generating magma. This magma is less dense than the surrounding rock, so it rises towards the surface, where it can eventually erupt as lava. This process is a key part of the Earth's geological activity, constantly renewing the surface of our planet. These processes, driven by the Earth's internal heat engine, are essential for creating the magma that fuels volcanic eruptions. Without this constant creation of magma, our planet would be a very different place. The heat and energy from the Earth's core drive the creation of magma, which in turn drives the geological activity that shapes our world. Without this molten underworld, our planet would be a far less dynamic and, dare I say, less interesting place. The constant movement and change within the Earth create the conditions for life on the surface, making our planet a vibrant, dynamic place. The birthplace of magma is truly the heart of our planet, driving the processes that make Earth a living, breathing world. Once magma forms, it doesn't stay put. Driven by buoyancy and pressure from surrounding rocks, it begins a slow, relentless ascent towards the Earth's surface. Think of it as a hot air balloon, lighter than the surrounding air, rising through the atmosphere. Similarly, magma, being less dense than the surrounding solid rock, is buoyant and tends to rise. The journey upward is not a simple straight shot. Magma, like a river encountering obstacles, must navigate through cracks and weaknesses in the Earth's crust. It may pool in underground chambers called magma chambers, slowly accumulating and increasing pressure over time. This upward migration can take thousands, even millions of years. The magma's composition can change during this journey, becoming more viscous or fluid depending on the minerals it encounters. These factors all play a crucial role in determining the nature of the eventual eruption. As magma accumulates in underground chambers, it begins a process that can take thousands of years or just a few days. These chambers, often located miles beneath the Earth's surface, act as reservoirs for molten rock. The pressure within these chambers begins to build. Imagine inflating a balloon. As you add more air, the pressure inside increases. This is a simple analogy, but it helps us understand the immense forces at play. As you add more air, the pressure inside increases. Similarly, as more magma enters the chamber, the pressure continues to rise. This pressure is not just from the magma itself, but also from the gases dissolved within it. This is analogous to what happens beneath a volcano. The magma chamber swells and the pressure builds up, pushing against the surrounding rock layers. Over time, this pressure can become immense. The influx of magma exerts immense pressure on the surrounding rocks. These rocks, though solid, are not impervious. They can bend, crack, and even break under the strain. This pressure is further amplified by the presence of volatile compounds dissolved within the magma itself. These compounds, such as water vapor, carbon dioxide, and sulfur dioxide, are trapped within the molten rock. These compounds, such as water vapor, carbon dioxide, and sulfur dioxide, act like the bubbles in a shaken bottle of soda. As the pressure increases, these volatiles begin to come out of solution, forming gas bubbles within the magma. Imagine shaking a bottle of soda. The carbon dioxide dissolved in the liquid forms bubbles, increasing the pressure inside the bottle. Similarly, in a magma chamber, the formation of gas bubbles increases the internal pressure. These volatiles begin to come out of solution, forming gas bubbles within the magma. The more gas bubbles that form, the higher the pressure becomes. Forming gas bubbles within the magma, this buildup of pressure is the driving force behind volcanic eruptions. The pressure continues to mount until it reaches a critical point. This buildup of pressure is the driving force behind volcanic eruptions. The surrounding rocks can only withstand this pressure for so long. Eventually, the pressure becomes too great for the rocks to contain. The surrounding rocks can only withstand this pressure for so long. They begin to crack and weaken under the immense strain. Eventually, something has to give. Eventually, something has to give. When the pressure exceeds the strength of the surrounding rocks, a spectacular release of energy occurs. This is the moment of eruption. When the pressure exceeds the strength of the surrounding rocks, a spectacular release of energy occurs. The magma, now under immense pressure, forces its way to the surface. a spectacular release of energy occurs. The eruption can be explosive, sending ash, gas, and lava high into the sky, or it can be more effusive, with lava flowing steadily from the vent. We call this a volcanic eruption. Each eruption is unique, shaped by the composition of the magma, the amount of gas it contains, and the structure of the volcano itself. But the underlying process is always the same, a buildup of pressure that eventually finds a way to release.